Yes. Welcome to my fourth session on the chapter of arithmetic progression. In our previous three sessions, we have covered up five formulas in arithmetic progression. An is equal to a plus n minus 1 into d. AP is equal to aq plus p minus q into d. D is equal to an minus a upon n minus 1. D is also equal to ap minus aq upon p minus q. And the formula for arithmetic mean capital A equal to a plus b upon 2. Let me take some few more sums dealing with the above formulas and then gradually start with finding the sum of an arithmetic progression. My first question over here is how many 3-digit numbers are divisible by 7? We start with the first question. How many 3-digit numbers are divisible by 7? Now, the 3-digit numbers that are divisible by 7, the 3-digit numbers that are divisible by 7 are, now the numbers which are divisible by 7 are 7, 14, 21. 7 is a 1-digit number, 14, 21, these are 2-digit number, but I asked you for the 3-digit numbers that are divisible by 7. Now which are those 3-digit numbers which are divisible by 7? The 3-digit numbers that are divisible by 7 are 105, 105 plus 7, that is 112, 119, and which is that last 3-digit number that is divisible by 7 is 994. Let me check. 994. 7 1 plus 7. 7 4s are 28. 7 2s are 14. The remainder here is 0. So the last 3-digit number that was divisible by 7 is 994. Now what is my question? How many 3-digit numbers are divisible by 7? So what is given to you? You know that the first term is 105. The common difference is 112 minus 105, which is 7. I know that the nth term is 994. I am asked to find out the value of n. So let me use the same formula. We know that a plus of n minus 1 into d is equal to an. We know that a plus of n minus 1 is equal to an. What is a? 105 plus n minus 1 into d, which is 7, and the nth term is 994. So what will I get in my next step? 105 plus, let's remove the bracket, 7 into n, 7, minus 1 into 7, minus 7 is equal to 994. So what is 7n equal to? 994 minus 7 going to the other side, plus 7, plus 105 going to the other side becomes minus 105. So you get 994 plus 7, that is 1001. From 1001 I subtract 105. From 1001 I subtract 11 minus 5 is 6, 9, 8. So I get 896. So what is n? N is therefore going to be 896 upon 7. 7 ones are 7 twos are 14, 7 eights are 56. So I get n as 128. What was my question? How many 3-digit numbers are divisible by 7? So how many 3-digit numbers are divisible by 7? 128. Let me take a similar question. The next one. The next question. How many multiples of 4? The second question. How many multiples of 4 lie between 10 and 250? What's my question now? How many multiples of 4 lie in between 10 and 250? Now which are the multiples of 4 that lie in between 2 and 50? The multiples of 4 that lie in between 10 and 250 are, I write directly 12, 12 plus 4, 16, 20, 24, and the last term is 248. So these are the multiples of 4 that lie in between 10 and 250. What is given is 12. What is the common difference? 16 minus 12, which is 4. I know that the nth term is 248. So what's going to be the value of n? What's going to be the value of n? Once again, I am using the same formula. We know that a plus of n minus 1 into d is equal to an. So 12 plus n minus 1 into d is equal to an. So 12 plus removal of bracket, 4 into n is 4n, minus 1 into 4 is minus 4, is equal to 248. So let me find out the value of n now. So 4n is equal to 248 minus 4 going to the other side plus 4 plus 12 going to the other side minus 12. So 248 plus 4 is 252 minus 12 is 240. So what is n equal? 4n equal to 240. So what would be the value of n? N would be 240 divided by 4. 4 ones are 4 six are. So n is equal to 60. My question, how many multiples of 4 lie in between 10 and 250? The multiples of 4 that lie in between 10 and 250 are 60. We go to the next type of sum. The next sum. The third sum. The 17th term of an AP, the 17th term of an AP exceeds its 10th term the 17th term of an AP exceeds its 10th term by 7. The 17th term of an AP exceeds its 10th term by 7. Find the common difference. What am I asking you in the sum? Is that the 17th term of an AP exceeds its 10th term by 7. What is given to me in the sum? The 17th term minus the 10th term is equal to 7. Once again I am using the first formula. An is equal to a plus of n minus 1 into d. What is A17? A plus of 17 minus 1 into d. What is A10? A plus of 10 minus 1 into d. So you get a plus 16d minus a plus 9d is equal to 7. So you get a plus 16d minus into plus minus minus into plus minus, this is equal to 7. Plus a and minus a cancels. So 16 minus 9 is 7d. So I get d as 7 upon 7. So what is the value of d? The value of d is equal to 1. Is it easy? Let's go to the next sum. Question number 4. Find the 20th term. Find the 20th term from the last term. Find the 20th term from the last term of the arithmetic progression. Of the arithmetic progression 3, 8, 13, dash 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 till 253. I have asked you to find out the 20th term from the last term. In this particular sequence, now what is given? The given arithmetic progression is 3, 8, 13 till 253. In this arithmetic progression, A is 3 and D is 8 minus 3, which is equal to 5. Whereas I have asked you to find the 20th term from the last term. Now when I reverse the arithmetic progression, the first term from the last becomes 253. Just before 253 you will have 248, 243 and your last term will be 3. Now I have written the same arithmetic progression in the reverse order because I asked you to find the 20th term from the last term. So to find the 20th term from the last term, what did I do? I wrote this arithmetic progression in the reverse form. So this becomes my first term. Now what is the common difference now? A2 minus A1. 248 minus 253, which is minus 5. I asked you for the 20th term. So what is A20? I asked you for the 20th term. So let me find out what is A20. Once again, the same formula. AN is equal to A plus of n minus 1 into D. So what is A20? It's equal to A plus 20 minus 1 into D. So what am I going to get? A20 is therefore going to be equal to 253 plus 20 minus 1, 19 into minus 5. So A20 is 253 plus into minus minus 19 5 the 95. So what is 253 minus 95 is 158. I have thus found the 20th term from the last term of the arithmetic progression. When I asked you to find out the 20th from the last term of the AP, what did I do? Just write the series in the reverse order. Okay, so with that we come to the end of sums based on arithmetic progression. Let us start with a new concept today, and that is finding the sum of the first n terms of an arithmetic progression. Today we will be finding the sum to n terms of an arithmetic progression. If I ask you to find the sum of the first 5 natural numbers, what is the sum of the first 5 natural numbers? Sum of the first 5 natural numbers is nothing but S5. What is S5 equal to? 1 plus 2 plus 3 plus 4 plus 5. I will get the answer very easily. 5 and 4, 9, 10, 11, 12, 13, 14, 15. But if I ask you, what is the sum of the first 200 numbers? What is the sum of the first consecutive 200 natural numbers? Now, I won't waste my time on counting 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, right up to 200. So for that, let me derive a new formula, that is formula to find the sum of the first n natural numbers. I am going to derive a new formula. The formula to find the sum of the first n natural numbers. Now what is the sum of the first n natural numbers? Sn is equal to 1 plus 2 plus 3 till n. If the last term is n, the second last term has to be n minus 1 and the third last term has to be n minus 2. I hope you have understood. If I say first 10 terms, 1 plus 2 plus 3 plus 4 plus 5 till 10. If the last term was 10, second has to be 1 less than 10, which is 9. Third should be 2 less than 10, which is 8. So if my last term is n, my second last term will be n minus 1 and my third last term will be n minus 2. Now what am I going to do? I am going to write the same sequence in the reverse order. What was last? Let me write first. What was second last? I am writing second. What was third last? I am writing third. And so on. What was third? Third last. What was second? Second last. And what was first? I am writing last. Now I have got two equations, that is equation number 1 and equation number 2. This is equation 1 and this is equation 2. Let me add the two equations. When I add 1Sn plus 1Sn is 2Sn. Let me add, what is n plus 1? N plus 1 remains as n plus 1. Let me add these two terms. What is n minus 1 and plus 2? N minus 1 when added to plus 2 again becomes n plus 1. N minus 2 when added to plus 3 again becomes n plus 1. This goes on. What is n minus 2 and plus 3? Once again I get n plus 1. N minus 1 plus 2. This again is n plus 1. Last term is again n plus 1. Now I have got n plus 1 n number of times. What do you mean by S5? The first 5 terms. S6, the first 6 terms. What is Sn? That means n plus 1 is there how many times? N number of times. So I have come to the new formula, that is Sn is equal to n into bracket n plus 1 upon 2. We have learned a new formula today, that is Sn is equal to n into bracket n plus 1 upon 2. This formula can also be represented as sigma n is equal to n into bracket n plus 1 upon 2. It can be represented as sigma n or it can be represented as Sn. Now what is this Sn? This is the formula to find the sum of the first n consecutive natural numbers. Sn is equal to n into bracket n plus 1 upon 2. Right? Now, supposing say I ask you to find the sum of the first 5 natural numbers. What did I ask you to find? The sum of the first 5 natural numbers. I just now found out the total. 5 plus 4, 9, 10, 11, 12, 13, 14, 15. But now I am using the formula Sn is equal to n into n plus 1 upon 2. If you are asked to find the sum of the first 5 natural numbers, what is this 5? 5 into bracket 5 plus 1 upon 2. So you get 5 into 6 upon 2. So 2 ones are 2 threes are. Is my total 15? Check. 5 and 4, 9. 9 and 3, 12, 13, 14, 15. I asked you a short while ago, find the sum of the first 200 natural numbers. Once again I am going to use the same formula. What is that? Sn is equal to n into bracket n plus 1 upon 2. Here I asked you to find the sum of the first 200 numbers. So 200 is equal to 200 into 200 plus 1 upon 2. So you get 200 into 201 upon 2. Cancel. 2 ones are 200s are. Multiply and you will get your answer. So what is the sum of the first 200 natural numbers? 20,100. We have learned a new formula today. What is Sn? N into bracket n plus 1 upon 2. If I ask you what is S5? 5 into 5 plus 1 upon 2. If I ask you what is S10? 10 into bracket 10 plus 1 upon 2. Now, if I ask you what is the value of S of n minus 1? When I asked you what is S5, it was 5 into 5 plus 1 upon 2. When I asked you what is S10, 10 into 10 plus 1 upon 2. Now I am asking you what is the value of S of n minus 1. What is S of? Same formula I use. Same number let me write here. N minus 1. Next number should be one more than this. N minus 1 plus 1 upon 2. So what happens? Plus 1 and minus 1 cancel. So I have come to the conclusion that S of n minus 1 is equal to n into n minus 1 upon 2. If I ask you what is the value of S of n minus 1, your answer will be n into n minus 1 upon 2. I take it as formula number 7. What is S of n minus 1 equal to? N into bracket n minus 1 upon 2. The two new formulas. What is Sn? N into n plus 1 upon 2. What is S of n minus 1? N into n minus 1 upon 2. There was a question asked in the annual examination. What is the value of sigma n plus sigma n minus 1 equal to? This can also be written as Sn plus S of n minus 1. Fill in the blank. What is Sn? Just now we have learned. What is Sn? N into bracket n plus 1 upon 2. What is S of n minus 1? S of n minus 1 is n into n minus 1 upon 2. LCM, you have a common denominator. When you have a common denominator, just add the numerator. So you get n plus 1 plus n into n minus 1. So you get n into n square, n into 1, n into n square, n into minus 1, minus n upon 2. What happens? Plus n, minus n, cancel. So 1n square plus 1n square is 2n square upon 2. So this 2 and this 2 cancels. What's your answer? N square. This was an objective question asked in the annual examination. I told you I can write it as Sn or I can also write it as sigma n. If you are asked what is Sn plus S of n minus 1, your answer is n square. Remember the formula. Sn plus S of n minus 1 is equal to n square. Remember, what is S of n plus S of n minus 1 equal to n square? It can also be written as sigma n plus sigma n minus 1. What is sigma n plus sigma n minus 1 equal to? N square. If I ask you, what is sigma n minus sigma n minus 1? Or what is Sn minus S of n minus 1 equal to? How am I going to do that sum? I have only changed one sign. Instead of plus I have put minus. So what will happen to my answer now? Common denominator. Numerator is n into n plus 1 minus n into n minus 1. So what will I get? N into n square, n into 1, n, minus n into n, minus n square, minus into minus plus n into 1, n. Here what happens? Plus n square and minus n square cancel. So 1n plus 1n is 2n upon 2. So what will be my final answer? N. If you are asked what is Sn minus Sn minus 1? N. Or what is sigma n minus sigma n minus 1? Answer is N. Let me write it as formula number 9. So Sn minus of Sn minus 1 is equal to N. If I ask you what is Sn minus 1 minus Sn equal to? Remember, Sn minus of Sn minus 1 is N. I am asking you a simple question. 5 minus 3, you know is 2. 5 minus 3, you know is 2. If I ask you the reverse way, what is 3 minus 5? What should be my answer? Minus 2. Am I right? If you know that 5 minus 3 is 2, 3 minus 5 has to be minus 2. Likewise, I know that Sn minus Sn minus 1 is equal to n. If I ask you what is S of n minus 1 minus Sn, your answer is minus n. Remember this as formula number 10. Sn minus 1 minus Sn is equal to minus n. Right? Now we come to the next unit, and here I will be teaching you another formula. Here I am going to teach you how to find the sum of the first n terms of a given arithmetic progression. A new formula to find the sum to n terms of an arithmetic progression. A very important formula. I am deriving a very important formula to find the sum to n terms of an arithmetic progression. Now we know that a typical arithmetic progression is of the form a comma a plus d comma a plus 2d dash 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 dash, where a is the first term, and d is the common difference. We know that the typical arithmetic progression is of the form a plus d, a plus 2d, dash dash dash, where A is the first term and D is the common difference. Let us assume, let the last term of the arithmetic progression be denoted by L. I am assuming the last term to be denoted by the letter L. Last term means nth term. Nth term is A plus of n minus 1 into D. So what is Sn? Sn is equal to A plus D plus A plus 2D. I have written the first three terms. Let me write the last three terms. If the last term is L, second last term is L minus D, third last is L minus 2D. What did I do? I have written the first three terms and the last three terms. Once again, just like how I had done in my previous derivation, I am writing this series in the reverse order. What was last, let me write first. What was second last, let me write second. What was third last, let me write it third. What was third last. What was second last. And what was first, I write it last. Once again I have got two equations. And once again I am going to add these two equations. Once again let me add these two equations. Now when I add 1 Sn plus 1 Sn is 2 times Sn. A plus L, unlike term, just keep it as it is. Let me add these two. Plus D minus D cancel. Once again I will get A plus L. Plus 2D and minus 2D cancel. Once again I will get A plus L. Plus 2D and minus 2D cancel. Once again I get A plus L. Plus D and minus D cancel. Once again I get A plus L. And the last one, I made a mistake. This is A. What was first? I had to write last. So the last term is also A plus L. Am I right? I started with A, ended with L. Here I started with L and I ended up with A. I am adding the two equations. So I get 2 times Sn. When you see Sn, that means A plus L is there n number of times. A plus L is there how many times? N times. If you see S5, you should know that there were 5 terms. If you see S10, you should know there are 10 terms. Since you are seeing Sn, that means A plus L is there n number of times. So I have come to a new formula that Sn is equal to n upon 2 into bracket A plus L. That 2 which was in the numerator goes to the denominator. I have come with another new formula. This is the formula to find the sum to n terms of a given arithmetic progression. Now what is L? But I know that L is nothing but the nth term, last term. Last term is nothing but nth term. So what is L? A plus of n minus 1 into D. So L is nothing but A plus of n minus 1 into D. That is the nth term of the AP. What is L? Nth term. Nth term is nothing but A plus of n minus 1 into D. So let me substitute. Instead of L, I will write A plus of n minus 1 into D. So I get Sn is equal to n upon 2 into bracket A, but instead of this L, I am going to write A plus of n minus 1 into D. Instead of this L, I am going to write A plus of n minus 1 into D. So therefore, I have come to the conclusion that Sn is equal to n upon 2 into bracket 1a plus 1a 2a plus n minus 1 into d. This is the second formula to find the sum to n terms of an arithmetic progression. We have learned two more formulas today to find the sum to n terms of an arithmetic progression. When should I use this formula? When I know the first term, last term and the number of terms. When should I use this formula? If I know the first term, common difference and number of terms that are there in the arithmetic progression. So I have come across two new formulas. Let me write those two new formulas on the board on the right hand side once again as formula number 11, which you know is Sn is equal to n upon 2 into bracket A plus L, and the 12th formula Sn is equal to n upon 2 into bracket 2a plus n minus 1 into d. Very important formula. The formula to find the sum to n terms of an arithmetic progression. There are two. When should I use the 11th and when should I use the 12th? I just told you. When shall I use formula number 11? When I know the first term, last term and the number of terms. When should I use formula number 12? When I know the first term, common difference and the number of terms. Let me just take one sum based on formula number 12. Find, very important question, the first 20 terms of the arithmetic progression 2, 5, 8. Find the sum of the first 20 terms. Let me say find the sum of the first 20 terms of the given arithmetic progression 2, 5, 8, 11. Here I am asking you to find out the sum of the series. So solution set 2 plus 5 plus 8 plus 11 plus dash to 20 terms. So what is A? 2. What is B? 5 minus 2, that is 3. What is N? 20. I asked you for S20. I asked you for S20, the sum of the first 20 terms. So let me use that formula. Sn is equal to n upon 2 into bracket 2a plus n minus 1 into d. So what is S20? S20 is equal to 20 upon 2 into bracket 2a plus 20 minus 1 into d. So what will I get? 2 ones are 2 tens are. 2 twos are 4. 20 minus 1, 19 into 3. So you get 10. 19 threes are 57. So you get 10 into 61. that is 610. What did I ask you? To find the sum of the first 20 terms of the given arithmetic progression. So that means I asked you 2 plus 5 plus 8 plus 11 to 20 such terms. I used formula number 12. I can also do this sum using formula number 11. If I have to use formula number 11, I should first find out the last term using formula number 1 and then use formula number 11. I should find out what is the last term. I can do the same sum using formula number 1, but there I'll have to use two formulas. First I have to find out A20, which is the last term. Once you know that A20, then your first term is known, the 20th term is known, n is 20, you will be getting your answer. Okay, we shall be doing sums on the other formulas in my next session. So thank you. See you for the fifth session.